If you want to know everything about 2x2 matrix inverse, then this video is for you. I want you to watch this video to the end. Welcome to Just Academy Mathematics, where we make you a mathematics genius. In this video, I'm going to show you how to solve a 2x2 matrix inverse. And I have an introduction here. Now, inverse of matrix, 2x2 matrix inverse. And a 2x2 matrix inverse can be derived as follows. So let's assume that matrix A is equals to A, B, C, D. Then A inverse, this stands for inverse, raised to the power of -1, stands for inverse. Then A inverse is equals to what? 1 over the determinant of A. 1 over the determinant of A. Now look at the next step you are going to take. This A here, you will bring it here. And this B here, you will bring it here. You will swap this A and B. Look at A, will come here. Can you see A down? And look at B, D rather. D will come up here. Are you with me now? Then these two here, you will attach minus to both of them. So you swap these two, attach minus to both of these. That is the procedure. Why are we doing that? That is the procedure to solving inverse of matrix. There will have been a better explanation to that, but sometimes you just need to accept a laid out procedure in mathematics and save yourself the stress. And you get what I'm saying? So all we need to do is to swap this, attach minus to these two. So by the time we proceed with the solving, we will get the inverse. But take note of the following with regard to inverse of matrix. There are a number of things I want you to take note of. 1, singular matrix or non-invertible matrix means that when the matrix is non-invertible or singular, it means that the determinant of that matrix is equal to 0. And because the determinant is 0, hence the inverse of that matrix is also 0. Or that matrix does not have an inverse. I get what I'm saying? Because when determinant is 0 here, you can see a determinant. It means that this expression is not defined. It has no inverse. That means A cannot have an inverse. I get what I'm saying? So we can say that A does not have an inverse when determinant is equal to 0. And when determinant of any matrix is 0, that matrix is a singular matrix or non-invertible. 2, for non-singular matrix or invertible matrix, the determinant of A is not equal to 0. So anytime the determinant of A is not equal to 0, that matrix must have an inverse. That is why we say that inverse of A is not also equal to 0. It's not equal to 0. I get what I'm saying? So A in this case must have an inverse because determinant of A is not 0. Then 3, product of a square matrix and its inverse is equal to identity. If you have a 2x2 matrix, or let's say you have set a matrix A times inverse of matrix A, or inverse of matrix A times A will give you what we call identity. If it is 2x2, 2x2 identity. If it is 3x3, 3x3 identity. And one more, inverse of inverse, that is inverse. When you find the inverse of an inverse, you get the matrix. So A inverse, or rather inverse of A inverse is equals to A. Okay, now let's swing it to action. We are solving just 3 examples. Now look at example 1. Look at example 1 now. Now for this first example, we are asked to do what? We are asked to find the inverse of A. Given that what? Given that A is equals to -3, 1, 2, 4, find the inverse of A. if you remember what I say vividly well, I said that the inverse of A is simply, look at what we're going to do. A inverse is simply equals to 1 over the determinant of A times, what do you do to this? You swap these two. 4 will come here, then minus 3 will come here. Then you attach minus to these two. That is what I said. So you have minus 1 here, I have minus 2 here. Are you getting it now? Now remember that the determinant of A, if you take it further, the determinant of A is minus 3 times 4, which is what? Minus 12 minus 1 times 2, which is what? 2. Of course, we have done determinant before, so you should not be surprised. Minus 3 times 4 is minus 12. Minus 1 times 2 is what? 2. Times in what? 4 minus 1 minus 2 minus 3. Are you with me now? So for us to find the inverse of A now, we say that A inverse is equals to 1 over minus 12 minus 2 is minus 14. Times in what? 4 minus 1 minus 2 minus 3. We can actually leave it like this, but let's put this value inside. If we multiply all of them with 1 over 14, of course, we are going to have minus 4 over 14. Minus times minus will give us plus. That is 1 over 14. Plus again, 2 over 14. And then plus again, 3 over 14. Are you following? So if you still want to take additional step, we can just reduce the value for the ones that can cancel. So finally, we have that 2 can go here. We have minus 2 over 7, 1 over 14, 1 over 7, and 3 over 14. This is A inverse. This is A inverse. This is A inverse. Are you following now? So that is how to go about it. That is A inverse you are seeing. Now, without wasting much time, let's move on. You remember you can play this video over and over again. Now look at example 2. Look at example 2. Example 2 says that we are to, given that B is equals to 2 minus 3, 4, 5, find B inverse, but not only that, show that B inverse times B is equals to this identity. This is what we call 2 by 2 identity, 1001. So we're going to show that, but before then we need to find B inverse. And to find B inverse, of course, you already know the procedure, that B inverse is equals to 1 over determinant of B times, we swap again, 5 will come up, 2 will come here, then we multiply these 2 with minus. So this one will turn to plus 3, while this one will turn to what? Minus 4. Are you with me now? So what is the determinant of minus B? That is 1 over determinant of minus B, 1 over this time, 2 times 5 is what? 10 minus 3 times 4 is what? Minus 12. Are you following? Times in 5 minus 4, 32. So what that B inverse is now equals to 1 over, this time this is plus, so 10 plus 12 is what? 22 times 5 minus 4, 3 and what? 2. Are you with me now? So if we of course put it inside, we'll have that what? B inverse is equals to what? 5 over 22, then 3 over 22, minus 4 over 22, and 2 over 22. Are you with me now? So we conclude again by reducing the value. That is, if we want to reduce the value, but we can work with this. I get what I'm saying? Without reducing the value, but let's just reduce it to the lowest term. So B inverse is actually what? It's actually 5 over 22, followed by 3 over 22. Nothing can go there. But for this one, 2 can go. So we have minus 2 over 11. And here we have 1 over what? 11. This is actually B inverse. Now that we know B inverse, we can now go and prove that we want to show that B inverse times B must be equals to what? 1001. That is what we want to show now. But let's pick the B inverse from here. Then we'll multiply it by B and see what happens. So let's pick the B inverse from here where they are uniform denominator. So B inverse is what? Is 5 over 22 minus 4 over 22, then 3 over 22, and 2 over 22. This is B inverse times B. What is B? 2 minus 3, 4, 5. So let's see if these 2 will give us this. That is what we want to prove. Now, of course, let's go ahead and multiply. But before then, I think to make it easy, I want to show you something. I think actually to make it easy, it's better we bring out this 22, common 22. In that case, we'll have even taken it from here. Instead of using this fraction to multiply, we can present this one. That is from here now. We'll have used this one. This is what I mean. 1 over 22 times 5 over minus 4, 3, 2, then times 2 minus 3, 4, 5. I think it's better now. So let's see what happens. Now, this will times this. Leave this one outside. Then this times this, of course. 5 row times column, row times column. 5 times 2 is what? 10. Plus 3 times 4 is what? 12. That is for this first row column. We have passed that stage. Then the next one, row column. 5 times minus 3, minus 15, plus 3 times 5 will give us what? 15. Are you seeing it now? Now, let's go to the second row times column. Minus 4 times 2, minus 8. 2 times 4, 8, comma. Minus 4 times minus 3, 12. Then 2 times, is it 12? Yes. Minus 4 times minus 3, 12. Then 2 times 5 will give us what? Will give us 10. That is plus 10. Are you with me now? So what do we have now? We have 1 over 22 times, this is of course 22, this is 0, this is 0, this is 22. Now if you put this 22 inside, you will now have 22 over 22. This is what I mean. So you will now have 22 over 22, comma, 0 over 22, 0 over 22, and 22 over 22. Of course, you can see now that this one will come out as what? It will come out as what? 1001. So we have succeeded in proving that B inverse, are you seeing it now? B inverse times what? B is equals to what? Identity. So let's take the last one for this class. Let's quickly run through the last one for this class. Now look at this. We are asked to find, given that A is equals to 2 minus 1 3, evaluate 2A minus A transpose or inverse, the inverse of everything inside that bracket. So first is for us to get that bracket, and to get the bracket, we start by getting 2A. What is 2A? Of course, 2A will be 2 times this. That is 2A. Are you getting it? 2 times this value. And 2 times this value means 2 times everything inside, which will give us what? 4 minus 2, 6. That is 2A. So that one is settled. Now let's go for A transpose. A transpose. What is A transpose? Of course, A transpose, we bring the row, make it column. If we bring the row and make it column, we'll have what? 2 here. Then second row become second column. It become minus 1 3. that is A transpose. Are you with me now? So we have 2A, we have A transpose. So the next step is to get 2A minus A transpose. And 2A minus A transpose is simply this minus this. That is 4 minus 2 6 minus 2 minus 1 2 3. Are you with me? And this will give me equals to what? 4 minus 2 is what? 2. 4 minus 1 is what? 5. Minus 2 minus 2 is what? Minus 4. 6 minus 3 is what? 3. So that is the value of what? That will give us the value of what? That will give us the value of the what? Of the 2A minus A transpose. So that is 2, and that is minus 4, and that is 3. Are you following now? So this place now, minus times minus is plus. So that is why here is plus 5. Are you with me? Now that we have gotten this A2A minus A transpose, the next thing now is to go for the inverse. So the inverse of 2A minus A transpose inverse now is equals to 1 over the determinant. What is the determinant? That is 2 times 3, 6 minus 4 times 5, which is minus 20. That is the determinant. Times, we swap this, we have 2, or rather we have 3 here. 3, 2, then we have minus 5 plus 4 when you multiply these two with minus. So the answer here now will be 1 over 26 times 3 minus 5, 4, 2. So when 26 go in, you have 3 over 26, then minus 5 over 26, 4 over 26, and 2 over what? 26. So we can conclude by saying that the final answer will not be 3 cannot go here, so we'll leave that place. We'll retain it. Since 3 cannot go in, 3 cannot go into 26, we'll retain it as 3 over 26. 4, 20, only 2 can go, so we have 2 over 13. The here remains 5 over 26, and here remains 1 over what? 13. Are you with me now? So that is the answer for this. And that brings us to the end of this class. Make sure you watch the next class. Very important. I'll be showing you how to solve the inverse of 3x3 matrix. Very important. There is a slight difference in the procedure. The inverse of 3x3 matrix. And remember, if you need a one-on-one tutorial, you want someone to show you step by step, just only you, to teach you, remember to reach out to us. Just Academy Mathematics, we are available. I get what I'm saying? So all you need to do is to reach us via our WhatsApp contact that is showing on the screen. Reach us via our WhatsApp contact, and we'll organize a one-on-one tutorial for you at an affordable rate. So make sure you follow us on our social media platform. We are YouTube, Facebook, or both at what? Just Academy Mathematics. Thank you. See you in our next class.